Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. We are presently studying marine boilers. In this lecture, we will learn about the uses of steam on ships which have been divided into the following groups. First, we will cover the use of steam for heating, fuel, and lubricating oils. Next, we will look at the heating of waste oil and sludge. Then, we will explore various miscellaneous heating applications. After that, we will explore the uses of steam for producing power. Then we will examine specific uses of steam on conventional oil tankers. Finally, we will discuss other miscellaneous applications of steam on ships. Let's go through these topics in the following slides. For heating, fuel and lubricating oils. Traditionally, the heating steam pressure on ships has been around 4.5 bar, corresponding to a temperature of 155 degree Celsius, which is sufficient to meet the highest heating demands. However, with the shift to low sulfur fuels, modern ships typically operate with heating steam at 3 bar pressure, resulting in a temperature of approximately 144 degrees Celsius. Fuel oil bunker tanks. Heavy fuel oil stored in bunker tanks is heated above its pour point, typically to around 45 degrees Celsius, to maintain pumpability and facilitate easy transfer. Fuel oil settling and service tanks. When heavy fuel oil is transferred to the settling tank, it is heated to approximately 75 degrees Celsius to promote separation and removal of water. After purification, the fuel is stored in service tank where the temperature is maintained prior to its use in the engine. Fuel oil drain and overflow tanks. Drain and overflow tanks, which may collect excess or drained fuel oil, are also kept heated to facilitate the transfer of oil back to the settling tank. Fuel oil purifier heaters. Before purification, heavy fuel oil is typically heated to around 98 degrees Celsius, which improves the separation of water from oil during centrifuging. Fuel oil heaters for main engine, auxiliary engine, and boiler. Fuel oil transferred from service tank to the engine is further heated to around 140 degrees Celsius, depending on the fuel quality, to achieve the desired viscosity of about 15 CST at the fuel injector for effective atomization. Main engine lube oil sump. Lubricating oil in the main engine sump may be preheated to about 40 degrees Celsius before starting the engine after prolonged stoppage. Normally, the oil is kept warm through the continuous operation of the purifier. Lube oil purifier heaters. Before purification, lubricating oil is preheated to around 90 degrees Celsius, which enhances water separation due to increased density difference. Main engine and auxiliary engine lubricating oil settling tanks. If the lubricating oil in the main or auxiliary engine is heavily contaminated with water, it is transferred to the respective settling tank and heated to around 70 degrees Celsius to allow water to settle before batch purification. Lubricating oil drain tank. Drained lubricating oil may be heated to approximately 40 degrees Celsius if necessary prior to transfer. Lubricating oil renovating tank. Use lubricating oil stored in the renovating tank is generally preheated to about 40 degrees Celsius before being recovered through a purifier. A steam trap T is fitted at the outlet of each heater to fully utilize the latent heat of steam. It allows only the condensate to pass and prevents steam from escaping until it has fully condensed, ensuring efficient heat transfer. The condensate returns to the hot well. For heating waste oil and sludge. Waste oils and sludge generated on ships are highly viscous and require preheating before disposal or transfer. Fuel oil sludge tank. Sludge separated by heavy fuel oil purifier is heated to approximately 60 degrees Celsius to facilitate its transfer. Lubricating oil sludge tank. Sludge separated by lubricating oil purifiers is similarly heated to around 60 degrees Celsius to enable smooth transfer. Scavenge drain tank. Main engine blow by particles mixed with used cylinder oil and collected in the scavenge drain tank are also heated to about 60 degrees Celsius before being transferred. Stuffing box drain tank. Likewise, leak lubricating oil from main engine cabin space and crankcase, removed via the stuffing box, is heated to around 60 degrees Celsius to aid in transfer. Separated bilge oil tank. Bilge oil separated and drained by the oily water separator is heated to approximately 60 degrees Celsius for easy transfer. Incinerator waste oil tanks. Sludge and waste oils transferred to the waste oil settling and service tanks are heated to evaporate any remaining water, making them suitable for burning in the incinerator. Steam tracing for oil or sludge. The temperature of heavy fuel oil and sludge oil during transfer is maintained using a small diameter steam tube that runs along the main pipe. This method is known as steam tracing. soot drain tank. Boiler washings and used chemicals collected in the soot drain tank are evaporated using steam to allow the safe disposal of soot ashore. Bilge holding tank. Bilge water collected in the holding tank is heated to around 50 degrees Celsius to enhance oil separation in the oily water separator. Oily water separator. The oily water separator itself is fitted with a steam heating coil to maintain a temperature of approximately 50 degrees Celsius, which improves the efficiency of oil separation. For miscellaneous heating applications, this slide highlights various miscellaneous uses of steam heating systems on board ship. Main engine jacket water heater. While the ship is in port, the main engine is kept warm by preheating the jacket cooling water using steam. Domestic freshwater heater. Fresh water for domestic use in accommodation and the engine room is heated using a steam operated heater called a calorifier. Accommodation air heater. During winter, the accommodation spaces are warmed by heating the air using steam based air heaters. Boiler warming up. When the auxiliary boiler and exhaust gas boilers are independent on motor ships, the auxiliary boiler is kept warm at sea and the exhaust gas boiler is kept warm in port using simmering steam. Freshwater generator. On some ships, the freshwater generator is equipped to operate in port using steam. This was more common on older vessels where port stays were longer. Boiler feed water heater. The hot well is usually fitted with heating steam to warm the feed water, which reduces the thermal shock to the boiler and remove dissolved gases like oxygen and carbon dioxide to prevent corrosion. Use of steam for producing power. Propulsion turbine. Earlier, ships were propelled by steam, but this has been replaced by diesel propulsion due to the low efficiency of steam in power generation. The latent heat in steam cannot be effectively utilized for propulsion and is wasted in the condenser. High pressure steam up to 100 bar was used for propulsion. Turbogenerator. On earlier ships, steam was also used to generate electrical power using high pressure steam up to 100 bar. Container ships carrying a large number of reefer containers require significant electrical power, which is met by the waste heat recovery system while the ship is at sea. On modern container ships, a turbogenerator driven by the steam from the diesel engine exhaust waste heat is used to generate electricity at sea. These turbogenerators typically operate at steam pressure of 6.5 bar. Cargo oil pump turbine. Auxiliary boilers on conventional oil tankers are primarily used to produce inert gas, ensuring the safety of cargo tanks against fire and explosion. The steam generated is also used for various associated processes. On conventional oil tankers, steam turbine driven cargo oil pumps are used for the bulk discharge of cargo oil. These pumps typically operate using 16 bar saturated steam, throttled down to below 9.5 bar. Feed pump turbine. Turbo feed pumps were used on steamships to supply feed water to the main boilers, operating with high pressure steam up to 100 bar. On tankers, turbo feed pumps are occasionally used to supply feed water to auxiliary boilers, operating on low pressure steam around 16 bar. Mooring winch and windlass. Mooring winches and windlasses were previously operated using low pressure steam at around 16 bar. Conventional oil tankers were often equipped with steam engine driven mooring winches and windlasses, typically operating on 9 bar steam. Modern ships, these systems have now been operated hydraulically. Stripping pump. A reciprocating pump operated by steam engine and commonly referred to as stripping pump is used to empty cargo tank after the bulk discharge. These pumps typically use steam at 9.5 bar. Turbo gas fan. On conventional oil tankers, steam turbine driven fan may also be used for gas freeing the cargo tanks. These are especially suitable for operation in hazardous tank deck atmosphere and typically operate at 9.5 bar steam. Specific uses of steam on steamship and tankers. Steam is specifically used for following purposes on steamships or conventional oil tankers. Air reactor. Steam was common medium to maintain vacuum in main and auxiliary condensers on steamships with air reactors. Vacuum in the condenser helps in improving efficiency of the steam turbine. Steam is also used to extract air from the auxiliary condenser, which is maintained under vacuum to utilize the maximum sensible heat of steam during turbine operation. 9.5 bar steam is used for this purpose. Some ships may use vacuum pumps instead. Cargo tank heating. Some cargoes require heating by steam during transportation to maintain fluidity. Due to large requirement, 9.5 bar steam is used for this purpose. Cargo tank cleaning heater. Cargo tanks are cleaned using hot seawater, especially when changing cargo grades or preparing the tanks for inspection or repair. Steam is used to heat the seawater typically at 9 bar pressure. Deck seal heating. The deck seal acts as a safety device of inert gas system to prevent backflow of cargo vapors towards the boiler if the inert gas plant stops. In cold climate, the seawater used in the deck seal is heated by 9.5 bar steam to prevent freezing. Miscellaneous steam applications. This slide covers the miscellaneous applications of steam on ships, after which the steam is exhausted. Steam at 9.5 bar or 6 bar or 4.5 bar is used for these applications. Main engine scavenge box fire extinguishing. Main engine scavenge boxes are equipped with fixed steam connections for extinguishing scavenge fires. For blowing sea chest. The ship's sea chest is occasionally fitted with a steam blowing connection to clear gratings or melt ice. For atomizing boiler fuel oil. Steam jet burners used in large boilers utilize steam for atomizing fuel oil. Accommodation air humidification. The ship's air conditioning system may be equipped with a steam injection arrangement to humidify the air during winter. For blowing boiler soot. Large boilers and exhaust gas economizers on motor ships are fitted with soot blowers that use steam to keep heating surfaces clean. For blowing horn. Steam operated horn was common feature on steamships. Conventional oil tankers were sometimes equipped with steam operated horns to alert the ship's crew or nearby vessels. This concludes our study of the various uses of steam on ships. This book has been written by me and covers all the topics as per the Indian Maritime University syllabus. It explains key concepts using simple illustrations. The book also includes answers to all the questions that have appeared in examination conducted by Indian Maritime University. It will help students prepare effectively for exams and also support them in working safely with ships' boilers. I hope you enjoyed the lecture. Feel free to share your feedback in the comment section. If you found this tutorial helpful, consider sharing it with your friends. Subscribe to the channel to stay updated with upcoming tutorials. I'll be back soon with a new lecture. Thank you for watching till the end.